Okay, so let's suppose that you saw this on test number 1. How would you solve that equation? Any ideas? I'm giving you a hint. What's the hint?
Take the square root of both
Square root
sides.
property, right? Take the square root of both sides. And first of all, recognize that this is what kind of equation?
Quadratic.
It's quadratic. So if you were to multiply, if you were to square that binomial, the first term would be 5x times itself, which is 25x squared. So it'd be quadratic. So it's a quadratic equation, and it's in that form to where you can use a square root property. So you're trying to get that variable x by itself. So you need to get rid of that exponent too. So you use a square root. The opposite of squaring is square rooting. But you got to remember when you do that, I'm going to go ahead and rewrite this over. So when you take the square root of both sides, what some of you are forgetting to do is that that's not quite correct. What am I missing in this particular case? That plus or minus. So you take the square root of both sides, you need that plus or minus notation. And so then what happens is that the square and the square root undo each other. And so you're left with that radicand, which is 5x minus 2 equal plus or minus, and then the square root of 32. What should you do with the square root of 32? See if you can simplify it, right? So you're looking for a perfect square other than 1 that goes into 32. So let's think about the square root of 32. And you always want to try and use the largest perfect square. So what's a perfect square that goes into 32 besides 1? 4. Okay. You could use 4. It's not the largest, so you would have to do some other stuff. What's the largest perfect square that goes into 32? 8's not a perfect square. 6 is not a perfect square. What do you, so besides 1, what's the next perfect square? 4. 4 goes into 32. 4 times 8, right? 4. What's the next perfect square? 9. 9 does not go to 32 evenly. What's the next perfect square? 16. Does 16 go to 32? Yes. What's the next perfect square?
25.
25. Does 25 go to 32 evenly? No. What's the next perfect square? 36, and that's beyond 32. So what's the largest perfect square? 16. So then what we notice is I can rewrite the square root of 32 as the square root of 16 times the square root of 2. And what's the square root of 16? So I get 4 square root of 2. So this becomes plus or minus 4 square root of 2. Now if you had used 4, like some of you said, you get the square root of 4 times the square root of 8. Square root of 4 is what number? So I get 2 square root of 8. But that's not simplified. Because what else do you know about the square root of 8? What perfect square goes into 8? 4. So I can write the square root of 8 as the square root of 4 times the square root of 2. And what's the square root of 4? So I get 2 times 2 times the square root of 2. And what's 2 times 2? 4. So you get 4 square root of 2. So it's always best to use the largest perfect square. All right, and so all you do then is just solve for x. Since this is an irrational number, not rational, irrational, you can leave it as plus or minus 4 square root of 2. But you got to get x by itself. So what's the next step?
Add 2 to both sides.
Add 2 to both sides. What you do to one side, you do to the other. And so I get, so the 2 and the negative 2 undo each other, so you get a sum of 0. So you get 5x equal, now this is 2 plus or minus 4 square root of 2. Those are not like terms, so you cannot say that's plus or minus 6 square root of 2. The only way that would be 6 square root of 2, this was a 2 square root of 2, and then 2 square root of 2 plus 4 square root of 2 is 6 square root of 2. But you also have that minus there. So you cannot combine those at this. You cannot combine those. And then one more step and you're done. What's the next step? Divide by 5. What you do to one side, you do to the other. So 5 divided by 5 is 1. 1 times x is x. You get x equals 2 plus or minus 4 square root of 2 divided by 5. Now in my lab, they ask you to separate the solutions. So in my lab, you would say 2 plus 4 square root of 2 over 5, comma, and then 2 minus 4 square root of 2 over 5. All right, so that was something similar to what you turned in Monday, one of the worksheets, except the one of the worksheets I think had an I in it. It was imaginary.
Can you push it up just a little bit?
Yeah. All right. Okay, so we only have one more part with section 1.5, and that's where we're going to solve a quadratic equation by completing the square. So make sure you're using this as we go over it. So let's look at this example. I'm going to remove this. Everyone wrote what they needed from here? Okay. All right, so let's look at this example. So let's suppose you want to solve by completing the square this time. Always follow directions. All right, so solve by completing the square. All right, so let's suppose we had this example. So number 1, we had x squared minus 8x minus 14 equals 0. So don't use the quadratic formula because that's not what that says. That says by completing the square. So eventually when you're completing the square, what's going to happen is that at some point, this quadratic equation will look like this. Some expression squared equal a number. That's what it's going to look like. So we complete the square, you're going to end up with something squared equal a number, which looks like what we just did, right? So once I get to that point, what's the next step? Get rid of the exponent. How are you going to do that? We just did it. Square root property. You can use the square root property. All right. So that's the idea of completing the square. So you're going to transform that equation into an expression that looks like that, and then you're going to get that parentheses by itself by taking the square root of both sides. All right. But you have to know how to get it to that form. Okay. So step number 1. If the coefficient of x squared is not 1, then you can divide both sides by that coefficient. What's the coefficient of x squared in the problem? It's 1. 1x squared. So we're good. We don't have to divide by 8, or 1 in this case. Number 2, rewrite the equation so that both terms containing the variables on one side and the constant is on the other. So do I have to do step 2? Someone said no, someone said yes. What's the answer?
Yes.
Yes, because it says rewrite the equation so that both terms containing the variables are on one side and the constant is on the other. What's your constant here?
Or -14.
Negative 14. So you want to bring them to the other side. So this becomes x squared minus 8x. I'm going to leave some space for a moment and then equal what number? 14. All right, so that's step 2. Step 3. And it's always going to be take half. So you're going to take half the coefficient of x. Now remember, you have an x squared and you have an x, so make sure you're doing the right one. What's the coefficient of x? Yeah, -8, not 8. It's -8. So what's happening is this. You're taking the coefficient of x, and what's the coefficient of x? -8. And it says take half. So taking half means the same thing as dividing by what number? 2. So when I do that, I get what number? -4. All right? So it says take half the coefficient of x, which I just did, and then what else must I do to that -4? Square it. So I'm going to take -4, and I'm going to square it. Now, what is -4 times itself? 16. Not -16, 16. All right, so that's step 3. So you're always going to take half the coefficient of x, and then you're going to square that number. So far, this one is not that bad because all those things we're getting are integers. I don't see any fractions at all. We're about to do one, but in this one there's none. Okay, then once you do step 3, then step 4 says I take 16 and do what to it? Add it to both sides. So then you're going to have this. You're going to say plus 16, just like that. And it's at this point, if you're doing all this correctly, it is this point that you can factor this trinomial, and it'll be that binomial squared. So in other words, if I'm doing this correctly, then this left-hand side should now be some expression squared. And that trinomial right here, if you do this correctly, it's called a perfect square trinomial. I think I have it written down. Yeah, number 5. It's called a perfect square trinomial, meaning that when you factor it, it's a binomial times itself. And it's easy to figure out what that binomial is. What expression times itself is x squared? No. Yeah. But that's not what I asked. Let's start with that first term right here. What expression squared is x squared? X. Okay. Now always look at the last. This number should always be a perfect square. So if you made a mistake and you got this to be, let's say 14, something's wrong because 14 is not a perfect square. All right. And then see that's a plus 16, and the middle sign is negative, right? All right. So what's the square root of 16? 4. So I'm going to put a 4 here, and that middle sign needs to be this one. So this becomes x minus 4 squared. So when you factor that perfect square trinomial, it's x minus 4 times itself. You can always check it, and you could do that mentally by using a fall method, right? So first is x squared, the outer is negative 4x, and the inner is also negative 4x, and then negative 4 times negative 4 is a positive 16. Combining like terms, you get x squared minus 8x plus 16, which is what this is. All right, and that's going to equal, and then what's on the other side? No, not 0. 14 plus 16. 30, right? Okay, so now that looks like number 1 that we did earlier. How do you get x by itself? What's the next step? Square root property. So you can take the square root of both sides. So square root, and don't forget that plus or minus. Okay, let's simplify the square root of 30. What's the only perfect square that goes into 30? 1. No other perfect square goes into 30, so I cannot do anything with the square root of 30 like I did with the square root of 32 earlier. So then all you have, the next step then is just going to be this. You're going to say x minus 4 equal plus or minus square root of 30. And one more step and you're done. What's the next step? Add 4 to both sides. And so you get x equal 4 plus or minus the square root of 30. Now in my lab, they're probably going to want you to separate those as a comma. So write it as two solutions separated by a comma. So in my lab, you'd say 4 plus the square root of 30, comma, 4 minus the square root of 30. So you have two irrational solutions. So two irrational. So those are irrational solutions. All right, now, this one wasn't that bad because there weren't any fractions involved. But when you do my lab, and it's not assigned yet, but when you do my lab, there are a couple of problems where you have fractions. So let's go ahead and do one with fractions. So this will be number 2. All right, so let's suppose we had this. All right, 2x squared plus 3x minus 2 equal 0. All right, now the directions indicate to do this by completing the square. Now the quadratic formula, because all of you can do it using the quadratic formula, but not all of you can do it by completing the square. So you have to know how to do that. Okay, what's the first step according to the handout? Okay, divide everything by 2, both sides by 2, right? So, because you want the coefficient of x squared to be what number? 1. So, all right, so basically you're saying this side divided by 2 and this side divided by 2, right? Now, the numerator right here has 3 terms. 1, 2, 3. All of those terms are being divided by what number? 2. So this becomes 2x squared divided by 2, which is what? X squared. Plus 3x divided by 2, just like this, right? Minus 2 divided by 2, which is what? 1. Equal, and then 0 divided by 2, which is 0. All right, so that's where I'm at. Same process as the previous problem, except now the coefficient of x is a fraction. So it's
and it's a fraction because we had to divide 2 by 3. I mean 2 and 3.
It's a fraction because when I divided both sides by 2, 3 divided by 2 is not an integer anymore, it's a fraction. So if this was a 6, and you divide it by 2, then that would just be 3x and not.
Okay, 3. So
okay, so the next step then, remember, is to bring the 1 to the other side, -1. And then we're going to leave some space. So I get x squared plus 3 halves x, leave some space, equal 1. Okay? All right, so now the next step says take the coefficient of x, and what's the coefficient of x? 3 divided by 2. So let's write that down. And then I take half of that. So you can think of that in 2 ways. Taking half means dividing by 2, right? Like that. Or it means multiplying by what? No, not 2. 0.5, which is what fraction?
Half.
1/2. So taking half of 3 halves means conceptually dividing by 2 or multiplying by a half. So I can do this if I want to. Those are equivalent. 3 halves divided by 2 is the same thing to say 3 halves times a half. Kind of makes sense because what you've learned in the past was that when you divide fractions, you can change it to a multiplication problem by doing what to the denominator? Taking the reciprocal. What's the reciprocal of 2? 1/2. So this part right here, that's easy, just looking at it. 3 times 1 is 3. 2 times 2 is 4. Over here, though, if you think about what I just said, dividing fractions, you can always change the division multiplication problem, by multiplying by the reciprocal of the denominator. What's the reciprocal of the denominator? The denominator is 2. What's the reciprocal of 2? 1/2, which now looks like this. All right. Now, once I get 3/4, what's the next step? I got to square it. So I'm going to take 3/4 and I'm going to square it. Now, remember we said whenever you square it, your numerator, in this case, your numerator and denominator better be perfect squares. So what's 3/4 times itself? 9/16. And is 9 a perfect square? Is 16 a perfect square? Yeah. And then what do I do to 9/16 now? Add it to both sides. So plus 9/16 plus 9/16, just like this. The left side is now easy. If you did all this correctly, the left side is now a perfect square trinomial. So, which means that when I factor it as a binomial squared, and think about what we just said earlier, what's going to be that first term right here? X. And the last sign's positive, so you have to take that middle sign. So it'll be x minus or x plus? X plus. All right, now, that number should be easy. What times itself is 9? 3. What times itself is 16? 4. So it's always going to be this right here. It's always that. So that's going to be 3/4. So x plus 3/4 times x plus 3/4. And if you really just wanted to check it, I'm just kind of remind you how to do that. So if you wanted to check it, I'm going to go ahead and do that here. So x plus 3/4 times x plus 3/4. What's x times x? Okay, what's the outer? What's x times 3/4?
3/4 squared.
3/4 x. And so whenever you're squaring a binomial, the outer and the inner should always be the same. So what's 3/4 times x? 3/4 x. Those have to be the same. And then what's 3/4 times 3/4? 9/16, right? Okay, now let's add these two terms. Okay, let's think about this. What is 3/4 plus 3/4? Say it again? Be careful.
6/8.
No. You don't, when adding fractions, you don't add numerators and add denominators. You got to find the common denominator, which you already have.
Which is 2.
What's 3/4 plus 3/4?
6/4.
6/4. 6/4. Reduced, it's what?
2.
3/2, which is what this is right here, right? Okay, so this becomes x squared plus 3/2 x plus 9/16, which is what we had right here. All right. Okay, now over here, we have to add those two rational numbers. So let's think about 1 plus 9/16. Several ways you can think about that. 9 plus 1/16 isn't, whenever you have a whole number and adding it to a fraction, you can just quickly write as a mixed number, couldn't you? So 1 plus 9/16, isn't that just 1 and 9/16? Oops, sorry, right here. 1 and 9/16. And then you want to rewrite this mixed number as an improper fraction. Do you remember how to do that? So remember what you do is you say 16 times 1 is what?
16.
And 16 plus 9 is 25. So you get 25/16. So 1 and 9/16 is 25/16. The other way to have done that, so where I'm adding two fractions, is to find the least common denominator. What's the least common denominator? 16. So I'm going to write two fractions with 16 as the denominator. The second one's easy. The denominators are already the same, so the numerators have to be the same. All right, now this is 1/1, right? Okay, so I need that denominator to be 16. So what do I need to multiply 1 by to get 16?
16.
But what I do to the denominator, I do to the numerator, so this needs to be 16/16. And so now the denominators are the same, so it's 16/16 plus 9/16. 25/16. So either approach, you get the same thing, but helpful to know both. So then this can become, right here, that's going to become 25/16. All right, so you did the hard part. Now the rest is easy. What's the next step?
Subtract 3/4. No, that's wrong.
Yeah, you get rid of that square, right? That exponent. First of all, you have to take the square root of both sides, and then you subtract 3/4. Just like this. Don't forget that plus and minus though, right? So this becomes x plus 3/4 equals plus or minus the square root of 25/16. I can reduce both of those because both of those are perfect squares. What's the square root of 25/16?
5/4.
5/4. Okay. All right. Now, just like we did in the past, in the previous problems, to get x by itself, I can subtract 3/4 from both sides. So this becomes x equals negative 3/4 plus or minus 5/4, right? So that's where I'm at. Now, remember what we did in the previous two problems. So in both of these that we did, these are both irrational numbers. The square root of 30 is an irrational number. And so notice how I wrote it. I wrote it in compact form. Just like that. But these right here, you can make that look better. Because both of those are rational numbers. Both of those, the negative 3/4 and the 5/4 are rational numbers. So what that means is this. I'm going to have to write it right here. Oops, sorry, right here. So what that means is this. Since both of those are rational numbers, I can write it as one fraction. So what that means is this. X equals negative 3/4 plus 5/4. And the other one is negative 3/4 minus 5/4. So x equals negative 3/4 plus 5/4, and then x equals negative 3/4 minus 5/4. Look at the first one. What's the negative 3/4 plus 5/4? 2/4, which reduced is 1/2. So there's one of your solutions. Over here, negative 3/4 minus 5/4 is what number? Negative 8/4, which is reduced is? Yeah, okay, negative 4/2, which reduced is? Negative 2, right? So those are your two solutions. So notice in the previous two problems, those were irrational numbers. So notice how we wrote it. Whereas these are rational solutions. So you write it in compact, you write it as a fraction. Yes?
On the worksheets, if we do solve a problem like this, would you care if we write the 2/4 or negative 8/4, or would you care if we just go straight to the?
Yeah, oh, you're saying, can you go from here to here?
Mm-hmm.
Yeah, it's fine. Yeah, you'd have to say 2/4 and negative 8/4. All right, so let's do one more with this. So number 3. All right, so we have 3x squared minus 2x equal 8. So the constant's are on the other side, but what do I need to do if I want to solve this by completing the square?
Divide by 3.
Divide both sides by 3. All right, so 3x squared divided by 3 is x squared minus 2/3 x, right? And leave some space, equal, and then 8/3. All right, so that's where we're at. Okay, now, the next step says to take the coefficient of x. What's the coefficient of x? Negative 2/3, though, right? And then I take half of that. Taking half of that means one of two things: dividing by 2 or multiplying by 1/2. Whenever you have a fraction, it's easier to multiply by 1/2. So I'm just going to times 1/2. And make sure you reduce it. It makes things easier if you reduce. So it's negative 2/3 times 1/2. Some of you are going to say negative 2 divided by 6, which reduced is negative 1/3. And then some of you, you probably said 2 divided by 2 is 1, and then negative 2 divided by 2 is negative 1. And so the numerator, what's a negative 1 times a positive 1?
-1.
Negative 1. The denominator, what's 3 times 1? 3, right? So half of negative 2/3 is a negative 1/3. Now what do I do to that negative 1/3? I square it. So what's negative 1/3 times itself? Not negative 1,
Positive 1.
not positive 1. 1/3, negative 1/3 times a negative 1/3. Write it out if you have to. Now let's do it again. Negative 1 times a negative 1. Negative 1 times a negative 1. 1. 3 times 3. So what's the answer? 1/9. Okay, what do I do to that 1/9? Add it to both sides. All right. The left-hand side should now be easy. That should now be a perfect square trinomial. So I can write it as a binomial squared. What is that binomial? What do you think? Two minus 1/3? X minus 1/3. It's okay. So x and then a middle sign and then 1/9. What fraction times itself is 1/9?
Negative 1/3.
Yeah. So x minus 1/3. Equal. Yeah.
Honestly, I'm being completely transparent. I feel like I'm going through the motions because you're talking me through it, but I don't understand. I don't know if I need to revisit some core algebra.
So I suggest that you go to that lesson and go through those videos again with that handout in front of you. And then you keep doing it until you're not just going through the motions.
And that's the lesson with the square root property.
Say it again?
That's the lesson with the square root property.
So lesson 1.5, I think it's Wednesdays.
Okay.
Today's lesson. Yeah. Okay. So, and then over here, you have 8/3 plus 1/9. How do I add those two fractions? Your least common denominator. What's the least common denominator? 9. So if the denominators are the same, then the numerators are the same. And then 8/3. I need the denominator to be 9, right?
Yeah.
So 3 times 3, 8 times 3, which is 24. So it's 24/9 plus 1/9.
25 over 9.
25 over 9.
Two perfect squares.
Okay? So if we're doing this correctly, both numerator and denominator have to be perfect squares. I'm sorry. It's not always the case here. No. But in this case it was. All right, so it doesn't always have to, both of them in this, for that concept right here, it doesn't always have to be perfect squares. It just happened in this case it was. What has to be a perfect square is this right here. Okay? What has to be a perfect square is what you add to both sides. So is 1 a perfect square? Yes. Is 9 a perfect square? Yes. Okay, now, what is the next step?
And square root.
Square root both sides. Plus or minus. Okay, so then the square root and the square undo each other. You get x minus a third equal plus or minus. And that fraction is nice because both the numerator and the denominator are perfect squares. What's the square root of 25/9? 5/3. And then that looks like the previous problem. 1/3 and 5/3 are rational numbers. So since those are rational numbers, you are expected to simplify this until you get fractions like this. All right, so let's go ahead and do that. So to get x by itself, you're going to add 1/3 to both sides. So 1/3 plus or minus 5/3. And since those are rational numbers, I'm going to write it as two separate solutions. So we're going to say x equals 1/3 plus 5/3, comma, and what's the other? 1/3 minus 5/3. Okay, what's 1/3 plus 5/3? 6/3, which is 2. So there's one of your solutions. What's 1/3 minus 5/3? Negative 4/3, and I cannot simplify that. So there's your other solution. And that is completing a square. So make sure it's the same process over and over. You just follow those steps. The only conceptualization that you should know is that in a perfect square trinomial, you can always factor it as a binomial squared. So this, conceptually, you should be able to recognize this. And then the other part is to get rid of that exponent. You take the square root of both sides, and then you go from there. All right, so that is the end of section 1.5. So you had 1.5 last week, and then this week you had completing the square 1.5. So we're done with 1.5. All right, now let's look at, so here is, I just printed it out for you. Just take one pass for the rest. There's the worksheet that came from the assignment, the graded worksheet. So there are how many graded worksheets this week? If you looked at it, there are 2. One of them is being passed around. Okay. Now, one of the other things you are going to learn this week, and I think came from Monday, so you should have already started it, is linear inequalities. So that's section 1.7. So linear inequalities. So if you know how to solve a linear equation, then you should have no problems with the linear inequality. So for example, number 1, 3 times x plus 5 minus x minus 2 is less than 4. So that's a linear inequality, not a linear equation, a linear inequality, because you have that inequality symbol, less than.
So this is a worksheet that we would take a picture of and turn in PDF, like we'd scan it as a PDF and turn it in?
Is this what we're doing right now in class?
No.
We
Yeah,
scan
home.
it. Okay. I was making sure this is something we scanned to turn in and not in person.
Okay, so you never, for graded work, you always submit in Canvas.
Okay.
So you're going to do that at home. I just copied it for you.
Yeah.
Oh, okay.
Okay? You're going to do your work at home. You're going to scan it and upload just like you did Monday's assignment and just like you did last week's assignment.
Thank you.
That makes sense?
Yes,
Yes,
sir.
Okay. All right, so if this was a linear equation, what would be the first thing you would do? Distribute. So this becomes 3x plus 15. Now be careful with this one. In this case, I'm going to distribute the negative 1. So negative 1 times x is a negative x. A negative 1, or the opposite of a negative 2, is a positive 2, and that's less than 4. Just like you've been doing with linear equations. What's the next step? Combine like terms. So 3x minus x is 2x. 15 plus 2 is 17, less than 4. If this was a linear equation, what would be the next step? Subtract 17 from both sides. So you get 2x is less than, and then what's 4 minus 17? All right, and then what's the next step? Divide both sides by 2. So I get x is less than negative 13 halves. All right, now if this was a linear equation, how many solutions would you have? No, if this was a linear equation, how many solutions would you have?
One.
Just one. What would it be? Negative 13 halves. And what kind of equation is that? Would that be conditional, inconsistent,
Conditional.
or identity? Conditional. So that would be a conditional equation. I think that was one of your My Labs that you had to work on that had that terminology. But how many solutions does this have? One solution? You say that this part right here only has one solution. Is that what you're saying?
Yes, infinitely many in one direction.
Infinitely many. This says that your solutions are any number that's less than what? Negative 13 halves. So any real number less than negative 13 halves. And how many real numbers are less than negative 13 halves? An infinite number. So when you do My Lab and when you do the assignment, it's then going to ask you, indicate the solution set in interval notation. So interval notation. So an interval notation is going to look like this. All right. So the way I would do that is I would first of all think about this in terms of a number line. So if you look at a number line, and I'm going to put negative 13 somewhere in that number line, negative 13 halves. And notice that it is strictly less than. You don't see a less than or equal to. That makes a difference. Less than, equal to, or just less than. So since I don't see an equal sign right here, less than or equal to, is negative 13 halves a solution to this inequality? No. It's just any number less than that. So since negative 13 halves is not a solution, what you're going to learn in those lessons is that when I put that in a number line, I'm going to use an open circle. An open circle means it's not a solution. And I'm going to shade in now all of the solutions. So all of my solutions are on which side of negative 13 halves? To the left. Less than. And then with an arrow. Yes?
Is the open circle and the parentheses the same thing?
Yeah, so you could also have done this. Just make sure it looks like a parentheses though, not a bracket. So those would be the same thing. All right, so open circle, parentheses are same thing. It means that that number is not a solution. Okay, now to do the interval notation, you read it from left to right. Always go from left to right. That arrow is pointing towards what idea? Negative infinity. So as you go from left to right, I'm going from negative infinity all the way to what number? negative 13 halves. And one of the things you learn when you did those lessons, if you haven't done it already, was that negative infinity and infinity are always parentheses. So you're going to say parentheses negative infinity. Make sure it looks like an infinity symbol. Comma, all the way to what number? Negative 13 over 2. Bracket or parentheses? Parentheses, because negative 13 halves is not a solution. And so that's your interval notation. You go from left to right. So once in your mind you have the idea what the graph looks like, you go from left to right. If this was a less than or equal to, and those less than or equal to, what would be the only difference here? Bracket where? Negative 13 halves. Infinity, negative infinity would still be with a parenthesis. All right, so that was number 1. Okay, let's go to number 2. All right, number 2, we have negative 8x plus x minus 6 is greater than or equal to 2. All right. What's the first step? Combine like terms. What's negative 8x plus x? Negative 7x minus 6 is greater than or equal to 2. What's the next step? Add 6 to both sides. So you had negative 7x is greater than or equal to 8. All right, now, what's the next step? Divide both sides by a negative number. Now, here's what you got to remember. And when you go through these lessons, there's more discussion about why you do this. But whenever you divide an inequality by a negative number, you have to reverse the inequality symbol. So when I divide both sides by negative 7, I'm going to circle this right here to remind myself I've got to reverse it. Whenever you divide both sides by a negative number, an inequality by negative number, you reverse the inequality symbol. So then that becomes, your solutions then would be x is any real number that is what? Nope. Less than or equal to negative 8 over 7. You reverse the inequality symbol. Greater than or equal to becomes what? Less than or equal to. And then you do it just like you did the previous one. So in this case, you have an even number solution. So in terms of interval notation, and you may want to, in your mind, think about what the graph looks like. This time you have negative 8/7, right? And previously, there was no equal sign. I used an open circle. Since there's an equal sign here, I'm going to use a closed circle. And I'm going to shade in every number that's to the left. Another way you could do this, instead of parentheses like we did earlier, you could use what in this case?
A bracket.
Bracket. Make sure the bracket's pointing in the right direction, though. It's going to be pointing to the left. So once in your mind you have what the graph looks like, then you go from left to right. So the arrow is pointing towards what concept? Negative infinity. So remember, infinity, negative infinity is always parentheses, comma, all the way to what number? With a bracket. Make sure it looks like a bracket. And so that's your interval notation. All right, now, just real quick, what if?
Excuse me, sir.
Yes.
In the first part of the parentheses, what is that before the comma?
Negative infinity.
That's the infinity sign?
Yeah, just like this. Yep.
Okay.
Yeah. Negative infinity. All right. So this is not going to be number 3, but what if you solve the linear equation, and this time it said this: x is greater than 4. What are the solutions, or any number greater than 4? What would the interval notation look like?
Open circle to the right.
Open circle. Interval notation. You don't use circles in interval notation. You can use them with graphs. But would it be bracket or parentheses? Parentheses pointing to the right, comma all the way to what? Infinity with parentheses. So the graph would look like this. Open circle going to the right with an arrow. And so remember, you always go from left to right, from smallest to largest. Smallest to largest. So I'm going from 4 all the way to infinity, parentheses. Now, sometimes, so when solving a linear equation, a linear inequality, most students prefer to have the variable on the left-hand side. It doesn't matter, but it usually helps if the variable's on the left-hand side. So, for example, suppose I had 3 is greater than or equal to x minus 1. Most students would just say, do what to both sides? Add 1. Add 1 to both sides. So you get 4 is greater than or equal to x, right? What would the interval notation be? Well, first of all, let's think about the graph. Let's think about the graph. Because once you know the graph, then it's easy to do the interval notation. So I have 4. What do I put on 4? Closed circle, open circle. Close. Everyone should know that. Close. Because of the equal sign. Okay, now, which side do I shade? Right or left?
Right.
Right? Why?
You said greater than.
Greater than? Okay. So let's think about that. So if I shade to the right, 6 would be a solution, wouldn't it?
Yeah.
Okay. Is 4 greater than or equal to 6? No, sir. No, it's not. 4 is not greater than or equal to 6. So shading to the right is not your solution set. Now, I did say greater than we go to the right. That's because what was on the left-hand side? X. Where is x? On the other side. So that means that if you see 4 is greater than x, that means that 4 is the largest solution. Everything else has to be less than that. So the graph then should be on this side. So the point being, when doing an inequality and you have the variable on the right-hand side, you need to be careful. So one way that students, when they do this, the next thing they do is they think this way. So if 4 is greater than or equal to x, then going backwards, that means x is what? Less than or equal to 4. And then it looks like this. Okay? So just be careful when the variable's on the other side. You could see that in my lab, and you could see it on test number 1. All right? Okay. Then the other thing with section 1.6 is that compound inequality. Compound inequality. So it looks something like this. So this is what the compound inequality looks like. And this idea, the way that looks, where you have two inequality symbols. That's going to be important when you see the next week or the week after when you're going to solve a absolute value inequality. So some of those absolute value inequalities you can transform like this. Okay, so that's a compound inequality. Compound, think two. Two inequality symbols. Notice they're pointing in the same direction. It's always got to look like that. That's a big lesson. Okay, now if I were to cover this part right here, let's say that's all we had. How'd you get x by itself? Add 1 to both sides and then do what? Divide by 3. If I had this, what would you do to both sides? Add 1 to both sides, divide by 3. So in solving a compound inequality, the idea is that you want to try and get that x by itself in the middle. And so to get x by itself, you're going to add 1 to all parts. There are 3 parts. So notice plus 1, plus 1, plus 1. What's negative 6 plus 1? So negative 5 is less than 3x is less than 5. What's the next step? Divide all parts by 3. And then you're done. You found your solutions. So my solutions are going to be any real number that is between negative 5/3 and what number? 5/3. So any real number between negative 5/3 and 5/3.
I'm gonna wait. I was gonna ask a question, but I'm sure you'll get to it.
What's your question?
I was gonna say, is it cool leaving a improper fraction on the right side, or do we have to know?
No, you just leave it as negative 5/3. That's the way I would do it. How many solutions are there?
Multiple in between those two.
Say again?
Would it be multiple in between those two?
What do you mean by multiple?
So any number between negative 5 over 3.
How many are there? How many real numbers are between negative 5/3 and 5/3? Huh?
And infinite amount.
An infinite number of real numbers. There's an infinite number. You have all those. If you look at this in terms of the number line, so negative 5/3, 5/3, right? Open circle, open circle. So it's any real number between those. So all your irrational numbers, like the square, maybe the square root of 2 is in there. Square root of 2 is in there. 0 is in there. 2, nope, 2 is not in there. Negative 1's in there. Positive 1. So all these real numbers, there's an infinite number. You have irrational numbers and rational numbers that are in there. So it's an infinite number. So you can't list them all. So that's why we either do it by a graph or we do interval notation. What would the interval notation be? Always go from left to right, from smallest to largest. Left to right. What's the interval notation? Left to right. Parentheses. Negative 5/3, comma. No, interval notation is just an interval.
So just the parentheses.
It's less than what?
So we just be the
You're going from negative 5/3 all the way to what?
5/3.
5/3. With a what? Parentheses. There's your answer. From negative 5/3 all the way to 5/3. All right, we're going to do one more with this. All right, suppose you had one, let's do one with a fraction. All right, so number 3. we have, this is number 4, number 4. We have 2 is less than or equal to 2/3 x minus 3 is less than 8. So we have this compound inequality. To solve this compound inequality, we're going to get x in the middle. So just looking at that, I know I can easily do what to all parts first? Add 3 to all parts. That makes things a little bit easier by doing that. So plus 3, plus 3, plus 3. And so then this becomes 5 is less than or equal to 2/3 x. It's less than, what's that, 11? All right, now, how do you get x by itself? You could divide all parts by 2/3. Most students have trouble with that. Remember a while ago you had trouble dividing by 2? A fraction divided by 2? Now you have a fraction divided by 2/3. Yeah, I would do what we've learned already. Clear the fractions. Multiply all parts by the LCD. What's the LCD? 3. So here's what it's going to look like. I'm just rewriting this over. Leaving some space. I'm going to say times 3, times 3, times 3. Just like that. No issue. I'm not dealing with any fractions. What's 5 times 3? 15. Less than or equal to. What's 2/3 x times 3?
2x.
2x. The 3's divide out. So 2x. Less than 33. One more step and you're done. Divide all parts by 2. And so your solutions would be any real number between 15 halves and what number? I'm sorry, I made a mistake here. That's divided by 2, right? So 33 halves, correct? All right. And so in terms of interval notation, what would the interval notation be like? You go from left to right. No, not parentheses, bracket, because the equal sign, because 15 halves is a solution. So bracket 15 halves, comma, all the way to what? 33 halves with a parentheses. So that's what it looks like. All right. Now, a while ago, some of you said this, and you have to be careful when you're dealing with fractions. So some of you said this. So some of you said divide by 2/3. Okay, well that's fine. Divide by 2/3. Okay. Then you got to think about this now. What is 5 divided by 2/3? Well, 5 divided by 2/3 means 5 times what? 3/2. Less than or equal to 2/3 divided by 2/3 is 1. 1 times x is x. Is less than 11 divided by 2/3 means 11 times what? 3 halves. But then you have to now say this. Well, what is 5 times 3 halves? What's 5 times 3 halves? 15 divided by 2, which is what we had here. What's 11 times 3 halves? 33 divided by 2. All right, so that's what you would have had to do. But it's a lot easier just to clear the fractions and then go that route. All right, so that was 1.7. So here's the worksheet dealing with 1.7. So real quickly, I won't be able to finish this, so just make sure you're you're going through the lessons dealing with what we don't get to. So then the other part that you have to look at this week is, and we're going to finish it next week. So this section is going to be in part of it this week, part of it next week. But this is section 1.6. Section 1.6, and it's called Higher Order Equations. Then the other part of that's called other equations. Higher order equations, other equations. When you look at my lab, there's all kinds of equations in there. So this is not an easy section. This right here. Not an easy section. So make sure you're looking at as many of those lessons as possible to get you through this. It's not easy. Not an easy one. So for example, let's look at this first one. Okay, so we want to solve this. We have x cubed plus x squared is equal to 16x plus 16. It's called higher order. One of the reasons it's called higher order here is because the largest exponent is bigger than 2. If the largest exponent was 2, what would the equation be called? Quadratic. Now, we could call this equation cubic, because the largest exponent is 3, but it's in the section called higher order. But I want to solve that equation. You really have enough information to do that. Now you may have forgotten most of it, but you have enough information to be able to solve this equation. Here's a way to do that. So in solving this higher order equation, you want to bring everything to one side and have 0 on the other. So when I do that, I'm going to get x cubed plus x squared minus 16x minus 16 equals 0. So that'll be your first step. It turns out that this particular equation, not all of them are going to be like this, but the ones you're going to do that looks like that, it turns out you can solve this equation by factoring. This can be done by factoring. Solve by factoring. Okay, but here's the thing you got to remember though. How many terms on the left-hand side? 4. Just out of curiosity, when you have 4 terms and you want to solve by factoring, or you want to factor it, what idea did you use when you had 4 terms? Factor by what? Start with a G. Grouping. Factor by grouping. So you're going to do this by grouping. And most times, not always the case, but most times when you do that, you group the first 2 and you grouped the last 2. So factor by grouping. So factor by grouping. So we can group the first 2, the last 2. So if we look at the first 2, x cubed plus x squared, what should GCF, the greatest common factor of x cubed and x squared? X squared. So I can factor out an x squared. So in your mind, or actually you're going to write it out, you're going to say x squared times, so x squared times what is x cubed? X. And then plus x squared times what is itself? 1. So when I factor x cubed plus x squared, I factored it as x squared plus x squared times x plus 1. Makes sense because when I think about the distributive property, x squared times x is x cubed, and x squared times 1 is x squared. Okay, so that's my first group. My second group, negative 16x and a negative 16. What's the GCF there? Negative 16. And always keep this in mind. Whatever that middle sign is right here, that's the one you're going to take out. So you're going to say minus, and then you're going to factor out a negative what? 16. Okay, now, if you're doing this correctly, if this is being, if you can use grouping here, if you do this correctly, this and this should be identical. So what should I have in that other parentheses? X plus 1. So let's check it. Negative 16 times what is a negative 16x? X. Negative 16 times what is a negative 16? Positive 1. Equals 0. Now let's look at those two groups. What do those two groups have in common? X plus 1. So those two groups, this group and that group, they have an x plus 1 in common. So now I can take that out. I can factor that out. So I get x plus 1 times, all right, now, if I factor out this x plus 1 right here, what's left? X squared. If I factor out this x plus 1, what's left? Minus 16 equals 0. So now what I have is x plus 1 times x squared minus 16 equals 0. I got to solve for x though, right? So what's the next step, do you think?
Step put down to 0.
Yeah, because remember, one of the things you had to turn in last Monday was where you just solve a quadratic equation by factoring. So you factor, and then you use a zero factor problem. You say each of those factors equal to 0. So remember the idea was this. I have two factors whose product is 0. Well, two factors whose product is 0, then it means one of them has to be what? 0. So the zero factor property says I take each of those factors and I set them equal to 0. That's what the zero factor property says. So I have two equations. The first one is what kind of equation? Someone said linear. The second one is what kind of equation? Quadratic. In that first equation, what's x? That's easy. You can tell me right away. Negative 1. All right, now let's think about the second. Think about what's the best way to solve that second quadratic, the second equation, which is quadratic. X squared minus 16 equals 0. Okay, so you could use the square root property by getting x squared by itself, because the x term is missing, right? Was that what you're going to say? Okay, so in other words, I can rewrite this as x squared equals 16, and then that's that square root property, isn't it? How do you get x by itself? Square root of both sides. But don't forget, when you take the square root of both sides, what else should you have? Plus and minus. So you get x equal plus or minus 4. How many solutions are there altogether? 3. Now in my lab, they're probably going to tell you to separate them. So you're going to say, in my lab, you're going to say -1, comma, 4, comma, -4. So that's how you solve that equation. So in my lab, there is one that looks like that. You're gonna solve by factoring. You have 4 terms. You're gonna group. Normally, what works is the first group, second group. You just follow the steps. Now I want to go back to x squared minus 16 because no one said this. How else could you have solved this equation? Huh? Factoring. You could have done factoring because I'm hoping you remember this. I'm hoping you know that this is the difference of 2 squares. That's the difference of 2 squares. So when you factor the difference of 2 squares, it becomes x minus 4 times what? X plus 4 equals 0. And then you do the same thing. You said each of those factors equal to 0. So x minus 4 equals 0. X plus 4 equals 0. So what's x? 4 here. What's x here? -4. So you get the same thing. Okay? All right. So that one you could have done 2 ways. So that's that. I told you the section was not an easy section. It does require, though, that you remember some things. Right, so let's look at another problem that's not going to be easy. Okay, so that was number 1. All right, let's look at this one. So this is not going to be easy. Let's look at number 2. So we have this higher order. We have this higher order equation. And I want to solve for x. What's the largest exponent? 4. There is no name for 4, so we just say a higher order equation. Like the previous one, we could say it was cubic. Now remember the previous one, when you brought everything to one side, so you have 0 on that side, right? In the previous one, when you brought everything to one side, you had 4 terms. In your mind, something should have clicked. If you remembered it, something should have clicked when you have 4 terms and you want to do factoring. You're going to factor by grouping. But here I don't have 4 terms. I have how many terms? 2. But look at that. You still want to use factoring, though. You want to use factoring. How are you going to use factoring with the left-hand side? Take out the starts with the G, the greatest common factor. Remember we used the word greatest common factor in the previous problem with the 2 groups? Same thing here. What's the greatest common factor of 4x to the 4th and a negative 16x squared? 4x squared. So I'm going to factor out a 4x squared. So 4x squared times, and that's going to be equal to 0. 4x squared times what is 4x to the 4th? X squared. Minus 4x squared times what is a negative 16x squared? Minus 4. So that's where I'm at. So I did the most difficult part, is recognizing the GCF as 4x squared. But then notice what I have. I have 4x squared times x squared minus 4 equals 0. What idea should come into your mind next? No. Okay, all right. You can't factor x squared minus 4. I'm not sure if that's what you meant. But y'all see you could factor x squared minus 4? So in other words, this right here. And so if I factor x squared minus 4, that's x minus 2 times x plus 2? So yeah, if that's what you meant by factoring, yes, that's true. But then at that point, what would you do? Using what property? called the zero factor property. So the zero factor property says that if I have two or more factors whose product is zero, like I have here, then one of those has to be what? Zero. So I said each one equal to zero. So regardless of which approach you took here you say 4x squared equals 0. And what's the other? X squared minus 4 equals 0. Here you would say 4x squared equals 0. What else? X minus 2 equals 0, and then x plus 2 equals 0. Now let's look at this one. If x plus 2 is equal to 0, then what's one of your solutions? 2. If x plus 2 equals 0, what's the other solution? Negative 2. All right, now look at this right here. Don't make this difficult. You can even think about what the answer is. 4 times what squared is 0? 0. 4 times 0 squared is 0, right? So what's x? 0. So you found your 3 solutions. Here, same thing, this same as that, so x has to equal what? 0. Over here, we can do like we did in the previous problem. Since there's no x, I could get x squared by itself, and then do what to both sides? Square root, plus or minus. So x equals plus or minus 2. So notice, regardless of which one you use, you get the same solution. It's not an easy section. You just got to keep working at it. All right, so that's about. I was going to do one more, but the one I'm going to do it's going to take a while. It'll look like this. So one of the questions on my lab, and I think I don't think you have any graded worksheet this week from this section, because I gave you the 2 already. Next week you may. But one of the non-graded worksheets, and remember, I'll make sure you work in the non-graded as well, right? Okay. Looks like this. X plus 5 squared minus 10 times x plus 5 plus 16 equal 0. And at that point, you're going to say, okay, I'm going home, I'm going to take a nap. I'm done for tonight. That one looks complicated, doesn't it? So when you study this section, so remember this section has all kinds of equations. When studying this section, notice what's inside those parentheses are identical, aren't they? Identical. So what's inside those parentheses? What expression? X plus 5. And so there's something called, and you've never seen this before, but there's something called substitution. So we could use the idea of substitution. So in my lab, they're going to say, solve this by substitution. And the way to do this by substitution is this. So what do I have? What do I see in those parentheses? X plus 5. So you have to now use a different variable. So let's use the u. So you'll notice that u is what is the variable we used. So you're going to say, well, I'm going to let u equal what's inside the parentheses. What's inside the parentheses? X plus 5. And so now what that means is that wherever I see an x plus 5, I'm going to replace it with what variable? U. So then this becomes u squared minus 10u plus 16 equal 0. That's what that becomes. So now I notice, hey, that becomes a lot easier to deal with now. Because it's a quadratic, usually that will be factorable. So I can do factoring here. If you can't remember how to factor with the 16 and negative 10, you could use quadratic formula. But it's factorable. When I factor those two binomials, what do you think you get? What do you think? So you want, so remember, this is trial and error. If something doesn't work, you try something else. So what two things multiplied by each other is u squared? U and u. Okay, the last sign's positive. That means that these signs in here have to be same or different? No,
Oh,
the same. A negative times a negative is a positive times a positive is a positive. So they'd be the same, and they're going to be that middle sign here. So both of these signs in here have to be what? Negative. Okay, now we got to think about 16. What two numbers multiplied by each other is 16? There's several possibilities. 8 times 2, 4 times 4, 16 times 1. What do you want to try? 8 and 2. Okay. So since those signs in here are the same, it doesn't matter, and that's a u right here, doesn't matter where I put the 8, does not matter where I put the 2. But you got to check, because you could have made a mistake, so FOIL it out. See what you get. FOIL this out. What's u times u? U squared. What's the outer? U times negative 2 is a negative 2u. What's the inner? Negative 8 times u is a negative 8u. And what's the last? A negative 8 times a negative 2 is a positive 16. Combining like terms, you have u squared minus 10u plus 16. So is that the same as this? So what I did was correct. Okay. Now, notice though, I went from the variable x to what variable? U. So I got to keep that in mind. So now I'm solving this equation. How do you solve this equation? Set them both equal to 0. So u minus 8 equals 0. U minus 2 equals 0. And so if u minus 8 equals 0, then what's u? 8. If u minus 2 equals 0, what's u? 2. But my original problem had what variable? X. So I got to solve for x. So that's where you come back now and resubstitute. What was u? X plus 5. So x plus 5 equal 8. And x plus 5 equal what? 2. And you just solve for x. Subtract 5 from both sides. What's your solution? 8 minus 5. 3. If x plus 5 equals 2 and you subtract 5, what's the other solution? Negative 3. And that's it.
Can you slide it down just a little bit, please?
Yeah. Down or up?
I mean,
Okay. All right. So those three were not easy. They were difficult ones. The good thing on a test is that I'm not going to ask you all those difficult questions, because then most of you would
Right.
So,
and you
Anyway.
said that we can go back and there's like videos.
yeah, when you go to the agenda, so when you go to the agenda, yeah, hold on.